Do you know you can calculate the angular velocity of a rod when it is freely falling from a vertical position to hit ground horizontally, as you know the length of the rod? Let's utilize the moment of inertia to determine this angular velocity easily. Let's take a look. When the rod is in a vertical position, it has a potential energy stored in it. While the rod is hitting the ground, this potential energy is converted into rotational kinetic energy. Thus, the potential energy is the source of the angular velocity of the rod. Therefore, we can write potential energy E of P is equal to angular kinetic energy E of omega, or mgh is equal to half I omega square. Here the two main variables are h, which is the displacement of the center of the mass, and I, which is the moment of inertia. We know that when the rod is vertical, its center of mass is exactly at the midpoint, and when it falls to the ground, the center of mass reaches the ground. Therefore, the displacement of the center of mass is h is equal to L by 2, where L is the length of the rod. On the other hand, as the rod falls to the ground, it rotates with angular motion, where the length of the rod acts as the radius of the circular path. For such a circular motion, the moment of inertia of the rod is given by the formula I is equal to 1/3 ml square. Now, substituting the values of these variables into the earlier equation, we get mgL by 2 is equal to half into 1/3 ml square omega square. Simplifying this equation, we find omega is equal to root over 3g by L. From this equation, we understand two things. First one, the angular velocity at which the rod will hit the ground is inversely proportional to its length. That is, the longer the rod, the lower the angular velocity. Second one, the angular velocity does not depend on the mass of the rod. It only depends on the length of the rod L and the gravitational acceleration g at that location. Thus, using this equation, we can easily determine the angular velocity of a falling rod if we know its length. For example, if the length of the rod is 1 meter, substituting L is equal to 1 and G is equal to 9.8, we find that the rod will hit the ground with an angular velocity of omega is equal to root over 3g, or 5.422 radian per second. I hope you have understood this concept. Stay with us for more explanation of physics concept using animations. Thank you everyone.